All right, we are jumping into section 6.2 and 6.4. We're looking at properties of different polygons. So we're looking at a rhombus here. And definitely go and check out these PowerPoint presentations that has all of this information. So we have all equal sides in a rhombus, but separate from a square, which also has 4 right angles. This does not. Then it also has these other properties about what we could say about what happens with the diagonal, and it bisects these angles. As you can see, it creates 2 equal angles here at 1 and 2, and 6 and 5, as well as 3 and 4, and 7 and 8. And then if we look at a rectangle, we have 4 right angles here. And then we also have the diagonals are equal to each other. And then a square has all of these properties. And then looking over at a parallelogram, we have opposite sides are equal. And then we have that their angles are supplementary. And we'll do plenty of examples. Here in this first one, we're doing that just same thing here. We're setting them equal to 180 and solving for the missing angle. Here, opposite sides are congruent, so we set them equal to each other and solve for x. Here, we see that we have equal lengths here, and therefore in this transversal, those must also be equal. So this is given as 20. That means this is also 20. And then to get the total distance, we simply add those together. Here, same as the first problem. Here, we're looking at our diagonals here. So we set these equal to each other. So we have this is y and this is x plus 1. We set that equal. And then this one here, 2y is equal to 4x plus 14. Since we have 2 different variables, we need to substitute. So I take this red one and I substitute the value of y in here, distribute, solve for x, and then it wants the value for y. So we simply plug that in to here and I get 13. Here I'm looking for WV, which is straight down here highlighted. I know that each of these is 2.4, and there are 3 of them, so I'd simply multiply times 3. Here I'm looking for TTU. My value is 3.5 for each of these sections, so I just multiply times 3. Here I have these opposite angles here, which are congruent. Set them equal to each other and solve for A. Here, I'm looking for the value of A. So we have lots of options here. So we could have set what is highlighted in green equal to each other, or I could have set what is highlighted in yellow equal to each other. I decided to do what was in yellow, so I did that and I get A is 23. In both cases, 3.5 plus this is also 23. So next step is then to find out the lengths of these sides. So we have opposite sides are equal, so I only have to plug it in for one of them. So I'm setting CD and AB are equal to each other. It's easier to plug it in here. I could have also plugged it in here, but I chose this one. So I plugged in the A value here and I get 25.2 for both AB and CD. And then for the next one, I know that they're equal to each other. I could either plug it in here or I could just simply use what is given. So I know it's 19.5. But if you plugged in 23.3 and subtracted 3.3, you'd also get 19.5 for BC and AD. Here, we know that this bisects it here, creating 2 equal angles. So we see that we're going to get all of angles simply by solving. So I let 2 and 4 be x, and 122 is given. Since it's a triangle, I realize it has to add up to 180. I solve, and I get all of these solutions. Here, I'm setting these equal to each other. I get my value of x. I also need to plug it in. I only need to choose one of them because I know that these diagonals are equal to each other. I chose a 2x plus 7. I plugged in my value of x to get 11 for both of them. Same will happen here. I set them equal to each other to find my value of x. I know that they're equal to each other. I just choose any one of them. I could have used 7x minus 3 or 5x plus 5. I plug it in, I get 25 for both of them. Here, the first thing we need to do is to set these equal to each other to find the value of y. The second thing I need to do is to find out the length of each side. So in doing so, I simply plug in that y value, and I have y minus 2, so 4 minus 2 is 2. Now I set that length equal to the side of 4x minus 6. It just so happens that it is also 2. That is not always the case. Here, we've got a parallelogram, and each of these angles here that's highlighted is going to be 90 degrees. These diagonals bisect it, so half of 90 is 45. So the 3x is equal to 45 as well as the 10z. We solve both of those. And then this last one here, 1 is looking at perpendicular angle here, which is 90 degrees. That's why I set it equal to 90. Solve in order to find y. Here, we're setting these equal to each other. Be sure to distribute this 3. So I get 3x minus 6 is equal to x plus 8. I solve to get the value of x. Then I need to, as you can see, that is not my final answer. I need to plug it back in. So since these diagonals are equal to each other, I chose x plus 8. You could also choose 3 times x minus 2. I did not. And so I know they're equal to both of these diagonals. I plug in the value here to get 15 for both of them. And the last one we're having to do with a quadratic. So I set these equal to each other. We have to move everything to the left side. So I subtracted 4x to get from 5x squared to get x squared. I add the 6x, nothing to add it to. And I just have minus 27, this equals 0. So you could either use the quadratic formula or you can factor. I factored, but it leaves you with 2 solutions. Since we're dealing with a solution here, we cannot use the negative 9. We use the positive 3.